Welcome everybody, I'm Jolene Moon. You've landed on my Science is Magic YouTube page where I talk about the science and maths that fascinates me. This is the first chemistry video in my GCSE Minecraft and Chill series where we just casually chat about the stuff that you're going to need to know for your GCSE exams, and I give you my study tips and strategies as a tutor with a bunch of experience. And while I do that, while we have this casual chat, I'm going to be playing Minecraft and getting up to some shenanigans. So grab a cup of tea, do whatever you're going to do, and possibly absorb some revision advice at the same time. Today's videos have a theme. Not all of them will have a theme, but these ones do, of FAQs and revision tips and strategies, as I said. And it's just no stress, low pressure kind of situation happening here. But we're going to be particularly talking about how you can improve your strategy between now and the summer if you are tuning in to this video at the time of posting, which is nearly the end of January. So as with, I highly recommend that you watch my other two videos because I do talk more generally about some strategies for particularly in the physics video, which will obviously be more relevant to this chemistry video. So you want to think about the general sort of science revision tips, but we're going to focus in more specifically on chemistry. And the biggest chemistry question I get is, why is chemistry so hard? I just want to set fire to powders and mix liquids and have fun. Why is it so difficult to get top grades in chemistry exams? And it's because of how specific chemistry is. So whereas with physics you have a small amount of leeway, not a lot, but you have some leeway where you're focusing on the more sort of the fundamental laws of physics of the universe, you know. Whereas chemistry, we're focusing down. We're talking about the little guys, the electrons and molecules that make up matter. Chemistry is sort of, people often say physics is applied maths and chemistry is applied physics, and then biology is applied chemistry, and it kind of, that does kind of ring true in certain perspectives and in certain ways, because the kind of truth of the matter is that chemistry is just a more focused down applied version of the principles that you learn in physics. And while, you know, I love both, I actually enjoy chemistry a lot more at school than I enjoyed physics, which I hinted at in my last video, because of claiming that physics is boring. It was a little bit boring at school, because you don't get the opportunity to learn the exciting stuff. Whereas chemistry, I think, understanding the nature of chemical interactions and what's going on, I think is way more interesting. And you start to learn the like proper bits of information that you need right away at the GCSE level, you know, calculating quantities of mass and things, whereas physics, you're learning foundational principles that are going to build your skills to understanding the really exciting stuff. So with that in mind, the thing to get your head around in chemistry, and why chemistry tends to be really hard for a lot of people, is because it will come down to the very, very specific individual behavior of every single element on the periodic table. However, what I would say to that is, you will make your job a lot easier if you can understand the periodic table. It is structured the way that it is structured for a reason, which you should learn about. Make sure you know why. It's because we group it, we order everything based on mass, and we group things based on their valence electrons, the electrons in the outer shell. So elements will naturally cluster in groups that behave really similarly because they've got the same interaction pattern with other elements. And the sort of similar principle is true across the rows as well. So the groups are the columns, and then we have the rows, which correspond to the valence shells of, and by valence I just mean the outermost, the outside. There we go, I've got a staircase, I can easily get back to my portal now. So I'm just going to be looking around. Basically, in the end, this is not going to be a very exciting video unless we happen across an end city. I'm going to be bridging between islands, and if you watch my maths video, you'll know why that's sort of vaguely relevant. We're talking about building bridges of knowledge between our solid ground of understood and remembered knowledge, and we've got to build bridges between them, and that's what revision is all about, really. But back to what I was saying, the periodic table, we've got systematic repeating patterns in the periodic table, and it's thought of, and my teachers told me that it's a map. The periodic table is a key to understanding all chemical interactions, and the periodic table is your map, your Bible, your guide, your cheat sheet, your everything you need to know about every element. So if you can really understand why it's structured the way it is, what groups things together, why do they behave similarly in that way, recognize the trends, the patterns, you're going to be ace in it. So that's the first thing. That's the first FAQ, and that's why usually if I've got a student and we're doing chemistry, first thing we'll go over is, do you understand the periodic table? Let's talk about the periodic table, and we can talk a little bit about how it was developed and built, and how we discovered different elements and everything on it as well. But mainly it's understanding the concepts, which is really, really important there. The next question I get is, how do the calculations in chemistry work? I am so very confused, and I understand that. For me, the most annoying thing about the calculations is how similar all the letters are. We've got N's, M's, MR's, C's, and V's, and they're all just very similar and clustered together. But if you have revised your maths, make sure you understand how to rearrange equations. Make sure in physics you understand if you use the triangles in your revision, if you lay out your equations in the triangles, you know how to cover one, and make sure that you're substituting in numbers into the correct part of the equation. That's going to be really key. For the two main chemistry equations are how to convert moles and mass using the molecular mass or the atomic mass of a substance, and the titration or the concentration equation, where you're converting between moles and volume to get concentration. So for that, like I said in the maths video, it's going to come down to practicing, making sure you set for yourself the same number of steps in the equation. And for more specifics on that, I would recommend that you watch, I haven't made a video yet, but I will be making a video soon on how to tackle those questions. So check those out. Give a subscribe to the channel to keep up to date with that. Now, the next thing is, what is going on with the mark scheme? Why am I losing marks even though I have sort of technically answered the question correctly? And again, like I said, very first thing I said in this video, chemistry is specific. So whereas physics, the mark scheme might be slightly more lenient in terms of if you've understood the principle correctly and you're describing the principle correctly, it's all good. You'll get the marks. In chemistry, you have to use the exact wording that they want. You have to make sure you've not mixed up any words. Make sure you are, really, really solid on your concepts, because you don't have a lot of room for error in chemistry. It is what specifically it is. It is what it means, and that can get really, really confusing. But the way to tackle that is to use exact words and definitions, so memorize those exact words and definitions. Use flashcards, use snap memory games. This is what I tell all my students. Make a set of cards where you have the prompts or the question. So like, what is the definition of the mole? And then on a separate card, you have the definition, the exact words as you would find it in the mark scheme. And then you build up a set of cards just like that for everything that you need to know, either for a topic or for the whole subject. And you put them face down and you play a snap game. So you try to find the answer and its corresponding question before a timer runs out, or you play it against other people and see who can get the most pairs, taking it in turns. And you sort of got to memorize where they are in the grid of cards that you've laid down on the table. And that's a really, really effective way of remembering things. If you can gamify or make puzzles or anything, like I said in my maths video, if you can treat it like a puzzle, if you can make it a puzzle or a game, you're going to learn it way, way faster. Amazing how much that can improve a grade. So grab those easy marks with the specific mark scheme wordings and definitions, because it's just memorization. All you've got to do is memorize things. And there's lots of, I'll do other revision tip videos where I talk specifically about memory games to incorporate. Brilliant. There is a city with a ship. Spot on. That's exactly what I need. Okay. Let's grab that. Okay, the next question is, what is going on with organic chemistry? I hate it. And same, honestly. That is big mood for me. Organic chemistry was the bane of my life, particularly at A level. It wrecked me. I was miserable, as was the rest of my class, trying to get to grips with organic chemistry. It's such a headache. And why do I say that? If you're not familiar, if you haven't quite got to that part of your course yet, but you're tuning in, good for you, getting in some revision early. But it's because all of the answers, all of the concepts are so similar. It's because they're all based on the same hydrocarbon skeletal structure, and obviously that is the only thing that's different is the functional groups, right? So you've got to treat it, or this is how I get around it. I treat it like there's like a base sim or a base creature, and the functional groups are like different powers that I'm putting into little spell slots or something, and I'm trying to build up a base creature into a particular monster that has certain powers. And might sound a little bit weird. Another way of thinking about it is that it's like you've got a base palette of colors and you are trying to add in different tones and different hues to make your image more interesting. Or you can think of it as, I don't know, different notes in a scale to achieve a particular sound in a song. Whatever it is, just think about you're adding little bits and pieces that to the same base that are overall creating a fundamentally different kind of character to either the molecule or chemical that we're talking about, and or like different seasoning in a base dish that's the same for every functional group. So like whether it's alcohol, whether it's carboxylic acid, whether it's the double carbon bond that make it an alkene versus the single carbon bond alkane, that's going to be a much easier way of conceptualizing what's happening. Okay, so that's my top tip for organic chemistry. What about inorganic chemistry? So this is where we're looking at metals, reactions, acid-base things, rates of reaction and kinetic theory in chemistry, structure and bonding, kind of everything else really that you come across in chemistry. And this was my favorite. I find this so interesting. I know that's not true for everyone. I appreciate that. So, what about if you can think of it as so I love alchemy. Alchemy was something that I got interested in when I was a teenager. And just imagine you are getting to go into your chemistry lab, put on your wizard or witch hat and your robes, and you're playing around with these powders and metals and liquids and just seeing what they do, seeing what happens. And then just trying to write down in your little wizard's journal, why does that happen? Um, and if that kind of exploratory, exploring your curiosity or getting to do cool effects and things with experiments, if that interests you, that's, follow that, because you sound like a chemist to me. If that makes you switch off immediately and you find it super boring, that's fair enough. But I love the idea of just being a little goofy guy playing around with beakers and Bunsen burners and chemicals and seeing what happens. It's fun. Um, but otherwise, if that's not your cup of tea, it comes down to practice, 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 practice the questions, practice explaining the concepts to your friends, to your parents, to your pets, to your plushies, whoever will listen, whatever's going on. Practice explaining it, because sometimes the thoughts in our head can get really muddled, and if you actually just take a minute to try and get the words out, try and verbalize it, that's sometimes easier of a connection than getting from brain to pen on paper in written words. So give that a go if you've never done that before. But if you have and you know it works for you, obviously this goes for any of my advice. If you know what works for you, do that. If you already think, oh yeah, I tend to do better at subjects when I do this with my revision, fantastic, go do that. Absolutely what you want to do. But also, as I said in physics, you've got to look at the questions and understand, and this, as I said in my maths video as well, understand the language of the question. What's the invisible question that they're asking you? What topic does this connect to? Sorry, if you know the headlines and you know the key ideas in any given I'm struggling with my word finding now. If you know the key ideas with any given subtopic of a topic or the subject, then you're going to be able to recognize what exam questions key to what subtopic, if that makes sense. So you want to get really used to recognizing those. My next tip, sorry, running in the wall there as I'm flicking my notes, is to gamify things. So I already mentioned this briefly a minute ago. Gamify things. If you know how to turn, if you this is a really good revision skill generally, and life skill really, I would say. But if you know how to turn things into a game, anything that's boring, turn it into something fun, you're going to be able to, you can learn anything. It's such a superpower. With chemistry, I would say turn things into images. So me and my friend and partner Tahel K are going to be doing a video on my channel soon where we're going to do a demonstration of what I'm about to talk about. So turn things into diagrams and oh no, okay. Let's just get rid of that Enderman. If you can put any concept that you need to know in chemistry into a diagram and then play Pictionary with your friends around said diagrams. So, for example, you have a prompt, which is something you need to know. So, let's say we need to know that there's a reaction which is acids plus bases will always make salt plus water. And you need to know that. And that's one of the things that you will be tested on in the exam. So you go away, you come back, you draw down. So if you had the prompt acid and base goes to salt and water, you might draw a vat of acid with a death or the chemical, the symbol, warning symbol for acid. And then you might draw a little box with a door, like a little classic Minecraft base. And then you might draw a tin of table salt for salt, and then you might just do some drops of water for water, and then see if your friends, if you've got 90 seconds of doing that, see if your friends guess that it's salt and water from acid and base. Now, I definitely don't want to go in without any slow falling potions or anything to help me out in here. Did I bring? I think I did. Let's put these shulkers down for a second. I think I'm low on arrows, is what I just saw there for a second. Oh no, I'm fine. Okay. No potions in that one. In that one, let's see if that works. Okay. Yeah. All right. Let's take some cobble. So, where was I? Oh yeah, making quizzes and games. I also the sillier you make it, the more fun you make it, the better. So I have an example quiz. Let me know if you want it. I'll drop the link down below. If there's a situation where you can turn the chemical elements of the periodic table, for example, if you're trying to learn the periodic table, make a personality quiz. So this is what I have an example of. So it's which chemical element are you? And it's just a silly quiz, the typical like BuzzFeed quizzes. It's just like that, but personality quizzes, memes, nonsense jokes, anything silly and goofy where you're using the concepts you need to revise, particularly if it's group projects or with friends. Another tip, and probably my final tip of the video, we're out of time, so I'll come back and conquer this city another time to get some shulker shells and to get an elytra. I'm an elytra person. Do you say elytra or elytra? Can't be dealing with elytra. It's elytra. Okay, so my last tip is do things with your friends like presentations. So if you can, like I said, verbalizing helps. Explain chemical concepts to your friends as though you're the teacher. So each pick a topic that you struggle with. So each of you go around, if you've got a group of friends or a group of classmates in like a group of 4 or something, each say which topic you find the hardest, go away, make a presentation, make sure the presentation has all the key ideas related to that particular little topic, and include all the key equations and definitions. Include at least one game on the slide, like a spot the difference slide or spot the mistakes, or just a little quick game on one slide. Make sure that you've got images, at least one image on every slide. Make sure that you've got at least one joke or meme or aid memoir for each concept. So like a mnemonic or a little poem or a joke or a saying, something that will help you remember that particular topic. And I think I will stop there. So I hope that was helpful. Thank you for watching all the way to the end here. I will be back next week with talking about mistakes, misunderstandings, and my personal musings. So if you want me to keep chatting and revising with you like this, don't forget to check out my other videos, maybe give a like and subscribe. But most importantly, don't forget to be kind to yourself. Don't forget to live your best magical life, because our words are spells. I hope you have a great week. All right, I will see you next time. Yalla bye.